Hello viewers, welcome to the eMath learning platform by Peter Ikaja. I am going to take you through binomial expansion using combinations, and this is specifically for the A-level mathematics students. Now, my contact details and the email are here below for any kind of question or clarification that you may need. My YouTube channel is also there for you to be able to access more of my uploads on YouTube. Remember to subscribe to always be updated whenever I upload new content. Now let's go direct and look at binomial expansion using combinations. Now, in this expansion, we are simply going to use a simple formula given by this. So we have it as U subscript r plus 1 is equals to n combinations r a power n minus r b power r. Now this C here in this case means combination. And now from this point, we're going to look at specific questions that always require this idea for simplicity. Number 1, find the term in x cubed in the expansion of 3 plus 2x power 7. And when you find such a question, what do you do? And what you do from our solution, we shall simply say using our formula, which is given by this. What are we going to do? We're going to simply take up the right-hand side expression, which we are very interested in and which is the most important, and equate it to kx cubed. Why do we equate it to kx cubed? Because they told us to find the term in x cubed. Now, in this case, k is going to be the coefficient of that term. So after this, you simply substitute. When you compare this with what we want to do, you realize our value of n is going to be this power here. So it means n will be 7. So it means wherever you see n, we shall be substituting for 7. But a will be the first term that we have, which is 3, and b will be the second term which we have together with its sign. In this case, it is a positive, so it will be 2x. But in case there is a negative, then you also include the negative when you're doing the substitution. Now let's look at that. I have simply substituted for n as 7, and where there is a, I've put 3, where there is b, I've put 2x. R will first keep there at this very stage. Then now, in the next step, for us to be able to get the value of r, we are simply going to compare the powers of x on both sides. Remember, on this side, we can only see there is a term here which has x with power r. So on this side, x is power 3. So by comparison, it means we shall just say we equate the powers of x, and that will give you r as 3. That will give you r as 3. So after getting the value of r as 3, we simply now also equate the constants. Now the constants, what do we mean by constants in this case? When you go back to this expression here, at this step here, now if x cubed is compared with x power r, it means k is going to be compared by 7 combination r, 3 power 7 minus r, then 2 power r. Remember, 2x is covered by the bracket power r, and so this power r is applied on both 2 and x. So it means our k will be 7 combination r, then 3 power 7 minus r, then into 2 power r. So that is what you're going to do in the next step as we're trying to explain here. So equating constants, our k becomes that, like we have explained. So the next step is going to be simply substituting for the value of r for you to be able to get the value of k. So when you substitute for r, we got r as 3. We just put it here where we have r. You also put it here and you also put it here. So that is what we do there. Then finally it will give you 7 combination 3, 3 power 4 and 2 power 3. When you press this in your calculator, you will surely come up with 22,680 as the value of k. But remember, the question asked for the term in x cubed, so we shall take kx cubed, but substituting the value of k. So we shall simply conclude and say the term in x cubed is 22,680 x cubed, and that will be our answer. Let's look at number 2. Now number 2, the setting is quite different now. They are saying find the coefficient of the term x power 17 in the expansion of 2 minus x power 20. What are we going to do here? Now the formula is going to still remain the same. We shall say n combination r a power n minus r b power r is equals to k x power 17. Why do we say k x power 17? Because they want the term, the coefficient of the term in x power 17. That is what we want to look at. So now in this case, what we are going to do, since they only want the coefficient, we shall still take kx power 17. X will help us to compare the powers and get the value of r, but later in the conclusion, we shall only conclude with the value of k because it is the coefficient. So what are we going to do? We're now going to substitute. Our n this time is 20, so we put 20 wherever there is n, and wherever there is a, we put 2, which you can see here, and where there is b, we shall put negative x. Take care of the sign, you have to go with it when you're doing the substitution. Then from this point, we are simply going to compare the powers again. I can see x here, power r. This negative 1 will be captured together with these other constants to give us the value of k. So if you compare, x will actually be, sorry, if you compare the powers of x, we shall be getting r coming to 17. After getting r as 17, what next? You simply go and also look for the constants now. So equating constants gives k as 20 combination r 2 power 20 minus r into negative x. I think this should be negative 1. Allow me do some correction on this. So that is supposed to be negative 1. Now from this point, we now substitute for the value of r. When you substitute for the value of r, remember we got 17. You substitute wherever you see r, and after that you press your calculator. 20 combination 17 to power 3 into negative 1 power 17. It will give you something related to negative 9,120. Then because the question was asking for the coefficient, we shall simply conclude with the value of k. So the coefficient of x power 17 is negative 9,120. Let's look at number 3, another kind of setting. Now, number 3 says find the term independent of x in the expansion of 3x squared minus 1 out of 2x cubed power 10. What do we do? Still, our formula will still hold. We shall use it. But this time round, since they say the term independent of x, they want the constant term. In other words, the term that does not contain x. But still, for us to proceed safely and smoothly, I am just equating this formula to kx power 0 because x power 0 is actually 1. And because x power 0 is 1, this is as good as equating this to k. But x power 0 is just to help us equate powers of x at some level, as we shall see. Now we have substituted for n as 10. You can see n is our 10. Then our a is 3x squared. B is going to be negative 1 out of 2x cubed. So that is how we have substituted. Then next to that, we shall simply again equate powers of x. But before we do so, make sure you first have a collective power. Because here we have x, we also have x here. But this x is squared, then also power 10 minus r. So these two will first multiply the 10 minus r to give us 20 minus 2r. Then we also have this power negative 3. And because there is multiplication between this bracket and this bracket, we simply add the powers. So it means when you're to add the powers, it will be 20 minus 2r. It would be plus negative 3. But saying plus negative 3 is as good as saying minus 3r. Then we equate it to the power of x on the right hand side, which is 0. So when you do that, you will get 20 minus 5r equals 0. And when you get the value of r, you will actually find it as 4. Now after finding the value of r as 4, you simply go back and do the substitution, especially when you're getting the constant term. Remember, the constant term is going to be these terms that are independent of x. 10 combination r, 3 power 10 minus r. Leave out this because it is not a constant term, but there is also negative half power r here. That is what we have. So substitute your value of r and press the calculator. 10 combination 4 multiplied by 3 power 10 minus 4 multiplied by negative half power 4. And when you do so, you will surely come up with something like 76,545, but divide by 8 in fraction form. But since the question was asking for the term independent of x, then it will simply be the value of k. So when they say the term independent of x, you simply state the constant term, which is in this case the value of k. Now, after these 3 comprehensive examples, I believe you can now try out the following exercise. So I've quoted for you the answers in brackets, and in case you find any issue with them, find no problem with consulting me through any of my contacts. Allow me say thank you so much. Wash out and wait for the next uploads. Make sure you go and subscribe to our YouTube channel for you to always be updated automatically whenever I upload new content. Have the best of your day.